Hi, Math 30-1s. Carrying on today with trig equations and identities, lesson 6. We learned several new identities today, okay, and they were referred to as the sum and difference identities. So in the title, obviously, we can see that sum, adding, and difference, subtraction, is what we are looking for when we want to use these identities to either prove something is true or eventually to solve an equation, which we will do in a couple of lessons. So just at the beginning of the lesson here, what they have is they have a table which shows us all the values, exact values, from our special angles and special triangles on the unit circle. So on the left-hand side, they have our three primary trig ratios, sine, cosine, and tangent. And then at the top, both in degrees and radians, they have our special angle measures, okay? And then the ratios below them that correspond to those values for those trig ratios, okay? So everything in that chart we should know, or we should be able to figure out and calculate as we move through these questions. The faster and the better that we know these special values, okay, the easier the questions will appear to be and the less time the questions will take. So just investigating what the sum and difference identities look like. Okay, we start with an investigation that says, look at the statement sine A plus B equaling sine A plus sine B. Now, a lot of us will assume that this is true because outside of the brackets, we have sine, so we normally like to distribute things, okay, when we have this scenario. But we're going to take a look at that and see what happens here. It says, determine whether or not the statement can be verified using angle A being 60 degrees and angle B being 30 degrees. Again, we are not at this point proving that this identity, if it is an identity, would be true for all values of x. We would just be looking to see if it's true for these specific values. So what I do is I treat the left-hand side and the right-hand side separately again. So the left-hand side. So that would be taking a look at the sine of 60 degrees plus 30 degrees, right? When I substitute those values in for A and B. So that would be equivalent to the sine of 90 degrees, okay, 60 degrees and 30 degrees, and the sine of 90 degrees is 1, okay? Again, either at that point you know, in your head envision what the graph of sine looks like, and at 90 degrees it hits a maximum value of 1, or if you know your table of values from the top of this lesson, you can see sine 90 degrees, okay, it does have a value of 1. Now I deal with the right-hand side, okay, and we'll see what happens here. So on the right-hand side, I would now have the sine of 60 degrees plus the sine of angle B, which would be 30 degrees. So the sine of 60 degrees is going to be root 3 over 2, and the sine of 30 degrees will be 1/2. So they do have a common denominator, so I can just simply bring the numerators together over that common denominator, so root 3 plus 1 over 2, okay, and I cannot simplify that any further. So there's my expression, root 3 plus 1 over 2, and obviously in this case you can see the left side is not equal to the right side. Okay, so they said determine whether or not the statement can be verified. It is not true, okay, and that's all that we have to write under this part of the question right here, okay? It is not true. Okay, moving on, we're going to do more of the same here in the next 4 questions. So again, you'll see knowing those exact values of those special angles is really important. Okay, so for the first one, it says use exact values, okay, and those are our ratios, our values from up above in that table, to verify the following statements. So on the left side here, we have the sine of 60 plus 30 degrees. So this would be the sine of 90 degrees. Okay? And we know the sine of 90 degrees is equal to 1. On the right-hand side, okay? On the right-hand side, I have the sine of 60 degrees. That's going to be root 3 over 2. The cosine of 30 degrees, okay, also root 3 over 2. To that, I have to add the cosine of 60 degrees. Okay, that's 1/2. And the sine of 30 degrees, which is also 1/2. Okay, so when I figure this out, I'm going to end up with 3 over 4 plus, okay, when I add these together, I get multiply there, so 1 over 4. And 3 over 4 plus 1 over 4 is 4 over 4, which is 1. Okay, so that one is verified. The left side does equal the right side. Okay, they both had values of 1. Okay, for the second one, I now have, and they switch to radian mode, okay, but if you have to kind of think in degree mode, that's obviously okay, but we want those exact values. So in this case, you would be dealing with the sine of, you have to go pi over 3 minus pi over 6, so you need a common denominator, which would be 6. So you would actually have 2 pi over 6 minus pi over 6, which is still pi over 6. So the y value of 30 degrees, okay, that is equal to 1/2. On the right-hand side, okay, what do we have here? Well, we have the sine of pi over 3, which is the y value, again, of 60 degrees. We're going to have root 3 over 2, okay? Cosine of pi over 6, also root 3 over 2, minus, okay, cosine of pi over 3, okay, that has a value of 1/2, and sine of pi over 6, which is also 1/2. So in this case, what do I have? Well, I have, again, 3 over 4 minus 1 over 4, okay, which works out to be 2 over 4, and 2 over 4 reduces to 1/2. So again, you can see the left-hand side does equal the right-hand side. Okay, 2 more. Cosine of 30 degrees plus 60 degrees, so this time we were talking about the cosine of 90 degrees. Cos of 90 degrees, either think of the graph of cosine or know your exact values from the table above. It has a value of 0. Then on the right-hand side, okay, what I'm going to have is the cosine of 30 degrees. That's root 3 over 2. Cosine of 60 degrees, that is 1/2, like so, minus sine of 30 degrees, 1/2, and sine of 60 degrees, that's root 3 over 2. So I multiply these together, you get root 3 over 4, minus, again here, this is also root 3 over 4. So anything minus itself always is equal to 0. So again, we end up in the scenario that we were hoping to achieve, which is the left-hand side equals the right-hand side. Okay, one more. Cos pi over 2 minus pi over 4. So this will be the cosine of pi over 4. Okay, you need a common denominator. So that is 45 degrees. The x value, that's root 2 over 2. Okay, the right-hand side now. Cos of pi over 2, that's 0. Cos of pi over 4, root 2 over 2. Plus sine of pi over 2, that's 1. And sine of pi over 4, root 2 over 2. So this obviously has a value of 0 plus root 2 over 2. 0 plus root 2 over 2 equals root 2 over 2. Okay, and again, the left side is equal to the right side. So without knowing it, what we've actually done as we turn the page here is we worked on and took a look at these 4 identities, okay? Sine A plus B, sine A minus B, cos A plus B, and cos A minus B. Those 4 identities you will find on your formula sheet at the back of the workbook, or again on any test or quiz, they would be on a formula sheet that's provided. So what that means is that if you have a scenario where you have sine A plus B, the sine of 2 angles that are being added together, you can expand it into this expression, or vice versa. If I have that expression, sine A cos B plus cos A sine B, I can write that as the sine of A plus B. So for all of these identities, we want to be able to go back and forth, okay, between the 2 sides of the identities, okay, depending on what the question is asking for. Now, below, what they're going to show us is how and basically to prove them, okay, and how to get the tangent of A plus B and the tangent of A minus B. I'm not really interested in doing that with you at this time just because of the scenario that we're in with our learning right now. So I just want you to know and be able to identify the sine of A plus B, sine A minus B, cos of A plus B, cos A minus B, and then at the bottom of the page, okay, obviously 2 more, okay, the sum and the difference identity for tangent A plus B and A minus B. And again, same as up above, you need to be able to go back and forth between these 2 forms of the identity, okay? And you'll see those, like I said, on any formula sheet or at the back of this workbook. That's where you'll find them so that they can help you with today's lesson and, moving forward with the lessons that remain in this chapter. So why would we want to do that, or, how are we going to use those identities? Okay, well, here's a perfect example. It says, express 15 degrees as a difference of 2 special angles and hence determine the exact value of sine of 15 with a rational denominator. So the first thing that should kind of, be an alarm in your head is that we're dealing with 15 degrees. 15 degrees is not a special angle. I don't know the ratios of that angle or that special triangle. But they're saying write it as a difference, which means we want to subtract using two special angles. Well, 15 degrees, okay, using two special angles could be 45 degrees minus 30 degrees. I know a lot about 45 degrees and 30 degrees, okay? I know the special values of those angles and their ratios. So what I do, and they want the sine of 15 degrees, okay? So instead of writing sine of 15 degrees, okay, which is what they are asking for, I write it as the sine of, and instead of 15 degrees, I write it as 45 degrees minus 30 degrees, okay? I split it up into two angles that I do know their special values. Now, this is going to be like sine A minus B. So all I do from the previous page is I follow the pattern for sine A minus B, which in this case would be the sine of 45 degrees, cosine of 30 degrees, and then we're going to subtract cosine of 45 degrees, sine of 30 degrees, okay? And I should know those values, okay? So you can see that's like sine A cos B minus cos A sine B, right? That's what we are basically doing. So now I fill in the values. So sine of 45 degrees, okay? This is root 2 over 2. Cos of 30 degrees is going to be root 3 over 2. Minus cosine of 45 degrees, that's root 2 over 2. Okay, and sine of 30 degrees is going to be 1/2. Okay, so when I multiply those together, you're going to get, I'm just going to move over here, so I'm going to get root 6 over 4 minus root 2 all over 4. Okay, they already have a common denominator, so I bring the numerators together. Root 6 minus root 2 all over 4. There is nothing that I can simplify or reduce there. And they did also ask for a rational denominator. Okay, but my denominator is rational there. Okay, 4 is a rational number. I don't need to rationalize anything, so that is my end answer. But hopefully you can see in that question when I want to use that, when we're talking about angles that we don't know the special values of the reference angles, okay? So same thing in 3 now, but again, this time we're discussing the angle in radian measures, so 5 pi over 12. And what they say here is express 5 pi over 12 as a sum. Okay, so this time we're going to add of two special angles and show that. So there's a couple issues here. Cotangent is equal to root 3 minus 1 over root 3 plus 1. I have to show that, which means when they say show that, that means at the end of the question, this is what I should be ending up with, root 3 minus 1 over root 3 plus 1. Okay, so that's what I'm going to deal with. Now, here's what I want to figure out. And I'll just do this on the side on the left here. 5 pi over 12. That's not going to be one of our special angles. But what I can do is take two special angles and add to get 5 pi over 12. And those two special angles would be pi over 4 plus pi over 6. Okay, 30 and 45 degrees gives me that value. So I've found my two special angles that I'm going to basically use in this case. Okay, so what I'm going to do is I'm going to basically work with tangent because that's the reciprocal of cotangent, and then once I get an expression for tangent, I will go 1 over that expression, which will basically give me the cotangent of that angle. Okay, so hopefully that makes sense. So what I do at this point is I go like this. Okay, the tangent of 5 pi over 12, which is what the question is asking me for, is going to be the tangent of, and instead of 5 pi over 12, the two angles I came up with, pi over 4 plus pi over 6. So in this case, this is my A plus the B. So I follow the pattern and formula for the tangent of A plus B, which is at the bottom of the previous page. So that's all I do from this point. I just fill in those expressions at this point. Then I'll deal with their special values. So what does this look like? Well, it looks like this. The tangent of pi over 4, so tan of A plus tan of B. Okay, so there's part 1. Tan A plus tan B. Now, in the denominator, I am going to have 1 minus tan of A, so tan of pi over 4, and tan of pi over 6. Okay, so I've filled in the identity. Now I need values for those expressions. So tangent of pi over 4, that's 1. Plus the tangent of pi over 6, that's root 3 over 3. Now that's just in the numerator, okay? In the denominator, you're going to have 1 minus, okay, the tangent of pi over 4, which is 1, and you have to multiply that by root 3 over 3, okay? So what you end up getting is the following. In the numerator, 1 plus root 3 over 3, and in the denominator, I get 1 minus root 3 over 3, okay? So at this point, that's the tangent of 5 pi over 12. You need to remember we want the cotangent of that. So what I want to do is I want to go 1 over that expression, right? So if I go 1 over that expression, what's going to happen? Well, the numerator and denominator are going to, in essence, end up switching, okay? So when I talk about the cotan then, so the cotangent of 5 pi over 12, okay, it's 1 over the expression I just had, which means I end up with 1 minus root 3 over 3, okay, and in the denominator I now have 1 plus root 3 over 3. Okay, at this point I need to rationalize because I have root 3's, especially in the denominator, don't I? So what I do is I multiply both the numerator and the denominator by the square root of 3, okay? And when I do that, what I end up with is the root of 3 minus 1 all over the root of 3 plus 1. Okay, remember what you're doing is multiplying this root 3, okay, by each of these expressions in the numerator and denominator, and I got exactly what I said I should get at the top of the page, root 3 minus 1 all over root 3 plus 1. Okay, so that's one way that these questions can be approached. Here's another way, okay? And these are typical questions that you will see, okay? They basically will show you what these questions look like, okay, in terms of them being expanded form of the identity. So what I mean by that is if you take a look at this first question, see how I have sine of 100, then cos of 100, and then I have cos of 10, sine of 10. The same angles are repeated over and over again. So if I look at those specifically a difference identity, and I know it's a difference identity maybe because there's a subtraction sign there, or it could be a sum identity. Where do I see sine cos minus cos sine? Okay, so you look at, if you want to, just the previous page, if you have the formula sheet with you, you look there. But where you see that, okay, if I refer to what I did in the 100 degrees in red is A, and the 10 degrees in blue is B. Okay, I'm looking for sine A cos B minus cos A sine B. Okay, and again, what you'll see is that is equivalent to the sine of A minus B. Well, if that's the case, then what this actually is the sine of my A value was 100 degrees, my B value was 10 degrees. So this is therefore equivalent to the sine of 90 degrees, okay? And we know the sine of 90 degrees has a value of 1, okay? So just like that. So when you see expressions that are separated by addition and subtraction and it's the same angles repeated over and over, okay, good chance that we can replace that big long expression with an identity and we can find the value or do the calculation relatively quickly. Now in B looks a little more intimidating, but it's really not, okay? It's the same kind of idea is that when you see here, look, I've got quarter pi minus theta, and here I also have quarter pi minus theta. Those could be my A's. These quarter pi plus thetas could be my B's, okay? They're repeated over and over again, and you can see you have cos minus sine sine. So you take a look at your sum and difference identities and find where do I have cos A cos B, and then minus sine A sine B. Well, that's going to be the cos of, if you take a look at it, it's going to be the cos of A plus B, right? That's the pattern I want to follow. So therefore, and again, this will take a little more time just because the expressions for A and B are a little more complicated. They're binomials. Here's what we have to do. It's going to be the cosine of, okay, A plus B. So A, right, we said was 1/4 pi minus theta. There's the A. To that, I have to add the 1/4 pi plus theta. Okay, so there's the A plus B. Now, when I do that, I get the cosine of, and I simplify in the brackets. Okay, 1/4 pi plus 1/4 pi would be 2/4 pi, which is half pi. Okay, so half of pi, and then I have negative theta plus theta, those cancel out. So it's just the cosine of pi over 2, which is like the cos of 90 degrees, okay, which is 0. Okay, all that work to end up at 0. But again, the toughest part of that question is identifying that is the expanded form basically of the identity cos A plus B. Okay, once you do that, the question kind of falls apart nicely, okay, and isn't too bad. All right, last question for today. It says, given that cos of A is 3 over 5 and cos of B is 5 over 13, where A is between 0 and pi over 2, and B is between 3 pi over 2 and 2 pi, find the exact value of cos A plus B. So very wordy and kind of intimidating for a lot of people, but when we have the restrictions that they've given me there on the domain for A and B, that's actually really important, and I'll show you why, okay? So what I'm going to do is draw, remember I like to draw diagrams here, just so that I can visually see what's happening, okay? So here will be my diagram for A, and here will be my diagram for B. Okay, again, I'll do A in red. So we'll do cos of A is 3 over 5. Okay, so there's the information for cos of A. And A is where? Between 0 and pi over 2. That's quadrant 1, isn't it? Right? 0 and 90 degrees. So I have some angle in quadrant 1. It looks like this. Right? There's A. Okay, in quadrant 1. And cosine is 3 over 5. Well, what's cosine? Cosine is the adjacent over the hypotenuse, isn't it? Okay? So that's what I have in quadrant 1 for cos of A. Cos of B is 5 over 13, but angle B is here between 3 pi over 2 and 2 pi. Well, that is in quadrant 4, isn't it? That's like 270 to 360. So here's angle B, okay, that we're dealing with in that quadrant, and it is adjacent over the hypotenuse. So in both of those questions, hopefully you can see I do not know the y dimension, okay, for those triangles, which will probably be important here moving forward. So what they want, again, is the exact value of cos A plus B. So if I take a look at, and I'm going to write this out here, the cosine of A plus B, well, that's my identity for cosine, right? So I take a look at cos A plus B, and I'm just going to write it out. I need the cos of A, cos of B. Okay, I have both of those. That's fine. What I do not have is what follows, minus sine A, sine B. I don't know those. So that means I got to go back to my diagrams and figure out the y values of those triangles and therefore come up with an expression for the sine of each of those angles. So for A, okay, in quadrant 1, how am I going to find y? Well, it would be 3 squared plus y squared will equal 5 squared. Okay, so that's 9 plus y squared equals 25. Y squared will equal 16. Okay, so y will equal 4. So therefore that means, okay, the sine of A, opposite over hypotenuse, would be 4 over 5. Okay, so there's the sine of A. I want to do the same basic calculation in quadrant 4 for B. So I go into B. Okay, again, this would be 5 squared plus y squared will equal 13 squared. So I have 25 plus y squared equals 169. Okay, so y squared will equal 144. Okay, I'll bring this up here. So y will have a value of 12, but because it's going down in quadrant 4, y is negative. So negative 12. So therefore, sine of B in quadrant 4 should be negative. It's negative 12 over 13. So now I have all the values I need for cos of A plus B. So cos of A, this was given to me in the question, 3 over 5. Cos of B, also given to me in the question, that's 5 over 13. Minus sine of A, I just figured that out, that's 4 over 5. And sine of B, I also just figured that out. That's negative 12 over 13. Okay? So what I need to do is multiply these together and subtract them. Okay, so what you're going to get in this case is you're going to get 5 times 3, which is 15, okay, and 13, so 5 times 3 is 15, 13 times 5 is 65, so 15 over 65. Now I'm going to put plus because I'm going to be subtracting a negative value, negative 12 times 4, right? So that's going to be 48 over 65. Okay, and that gives me a value of 63 over 65, okay, which is an exact value, and I cannot reduce that at all, so there is my final answer. Okay, so that's the value of cos A plus B. 63 over 65. Okay, so work on that tonight, you guys. Be familiar with and get comfortable with that formula sheet, going back and forth between it. If you want to photocopy it and just have it beside you all the time, if you want to flip back and forth between it, or just use it when it's printed out in this section of the notes, it doesn't matter to me. Just be able to find them and be able to work with them. Okay, again, as always, any questions, forward them to me and I'll get back to you as soon as I can.